Hi friends, welcome to follow up. Let's have a look at problem 974, subarray sums divisible by an integer key. So this video is a follow-up for previous video. Let's continue practicing the reduction of problem or using data structure to solve problem. So here we are given an integer array called nums and an integer key. So we want to find the number of non-empty subarrays that have a sum divisible by key. So here a subarray is a contiguous part of an array. So here we have two examples. Example 2 is very special because we need the subarray to be non-empty, so the only subarray is the nums itself, right, for non-empty ones. Then the key here is 9, right? So 5 is not divisible by the key, so we return 0. For the first example, the output is 7. So there are 7 subarrays with the sum divisible by key. So in the explanation, the problem lists all the possible subarrays. So here the constraints are the following. First, the nums list can be as long as 10 to the power 4 multiplied by 3, right? So the elements in the list can be negative, can be 0, and can be positive. So here key is strictly positive. So with that said, basically we are ready to look at the coding and the logic. So here the prototype problem is again find number of subarrays with sum equal to a given number. So here we want to find subarrays that have a sum divisible by key, right? So in this case, we're still going to use dictionary or hash map abstract data type to solve this problem. So here we're going to use dict or hash map, right? So for this problem, first, because it's related to counting, so we are going to initialize a variable called result. So this result is used for counting, the number of valid subarrays. So here valid means that their sum is divisible by key. So again, so we are going to use a dictionary. So this dictionary is going to store the remainder and the corresponding frequency. So here the remainder is the remainder sum modulo the key, right? So the logic will be the following. So here we are going to add 1, 0, right? So 1, the count frequency is 1. The logic is the following. So the logic. So if starting from index 0 up to index I0, right? So we have a sum, right? The sum corresponding to a remainder R1. And then we have another one, a larger index. So up to I0, then continue up to I, right? Let's assume that this sum has a remainder modulo key, that is R2, right? So if R1 and R2 equal, right, it means that the subarray starting from I0 plus 1 and ending at I, right, have sum divisible by the integer key. So that's the main logic. So we want to record this information using the dictionary. So it's possible that we can start from index 0. So this corresponding to, so we have a remainder 0 corresponding to a count 1. It's counting nothing, right? So now we are ready to do the simple for loop. So let's use a current. So the current is to this is a running sum up to an index. So in this problem, we do not need to specify the index, but we need to understand the logic and add the hood, right? So then we can iterate for y in nums. But if you like, you can use for I and y in enumerate nums. So for I, y in enumerate nums. So, but you know, the index does not come into play explicitly. So we will not. We just use the for the simple for loop. So in this case, what we want to do? So we are going to get current. So this current will be the sum up to the current index, say I, right? So the R, the remainder, will be current modulo this K, right? Then we want to check how many times this remainder have already appeared in the dictionary. It means that corresponding to those number of indices, there are some with the same remainder as this R. Then from those index starting there onwards and ending at the current index, they are corresponding to subarrays with sum divisible by K. So then we are going to increment the result. So we want to call get the remainder, right? So their frequency. If not, we are going to get 0, right? Then afterwards, so we want to store the current remainder, right? Because the current remainder at this index appears once. We need to count in the following rounds. So in this case, so we get the previous frequency and then increment by 1. So the increment by 1 is due to this one, this current R. So with that said, basically we are ready to return the results. So before we make any comments, let's first do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So here, this problem again provides us a very good example of using data structure to solve problems. So we would see here the main point is to reduce the problem to a known prototype problem, and then once you realize the connection, then solving this problem or writing the code is rather straightforward. So with that said, that's about it for this problem and for this video.